We were introduced how can we use the Docs2KG to process your own documents. So in generally, as we show in this picture, your input can be ebook, HTML, PDF, Word, and if you want to extend it, it can be Excel, emails, all the things. The output of it will be unified into Markdown, table, JSON, and the figures with descriptions. So the metadata about all of the documents, it will go through the metadata extraction and the metadata knowledge graph construction process, have a over like a high level metadata knowledge graph. And then for each individual document, it will go through a dual pass document digitalization process. If it's a native digital files like the HTML and the generated PDF, it will go through this native digital pass. But if it's a scanned PDF or it's an image, it will go through this OCR pass. For example, use the layout processing and then OCR. And after these two steps, it will be output unified into a markdown format for the text, and the tables will be in the JSON format, and the figures will be with the descriptions. Then this data will be fed into the layout loaded graph construction process. So for each document, you will have a highest level like the title, and then you have different sub-levels of headings, and they are close to each other. So that's basically what is being illustrated here. So the text will have this tree structure, and then it will link the images and the tables to the graph. And for the semantic one, it's actually more modelized. So it will go from the bottom up and the top down. Both of them we will try it because as naturally, the logic graph construction process in our real life won't be able to have a perfect ontology to guide you to construct it because we need to learn from the knowledge itself to catch up what's in the real world. But it won't also be totally not ontology based. So like totally is based on the human effort because as a human society until now, we already gathering, collecting a lot of knowledges and have this kind of ontology or the knowledge of ontology already. So we will apply both of them. So from the top down is we're trying to use a large language model with a human together to do the ontology creation. If in your domain you already have ontology, then you can just transfer it into the format we required and put it here. So you will have the ontology. And normally for most of the companies, enterprises, organizations, they actually should be able to have an entity list, which is already lying down in their relational database. That's a common case. For example, the data we're processing is from the GSW. They have 200,000 entity lists in their good, very, very good relational databases. It actually makes sense because for the companies, their core assets will be digitalized into the relational database in these past 30 to 40 years. So that's a valuable asset for us to construct the logic graph. So we should use that. So one way is bottom up is we use the entity list and we do the match, use the spicy or the exact match to extract that entity from the document, or we use the NER models. For each specific domains, you have a lot of different NER models. You can use that NER models to detect the name entities. Or like recently, more interesting ways is you use a prompt-based way to do the extraction. Most of the packages like the NameChain and NumIndex, they actually use this way. So they just ask you to extract the knowledge graph. But that's not a good way. Actually, a good way should be ontology guided or ontology based, prompt based extraction. That's what we implemented, but none of them will be perfect. And depends on your scenarios, you should have more different modules can extend it from here. So after the semantic knowledge graph was constructed, you will have these two together. But that's where most of the research or tools stopped at. However, will this knowledge graph be ready for the production usage? I don't think so. That's why we introduced this human in the loop quality insurance. We understand that in the end of the day, we want to get rid of the human effort in this pipeline. But now we need to work collaboratively with the large language models, the pipeline together to ensure we understand what is a high quality logic graph we want to achieve. And during this loop, then we increase these kind of models gradually. In the end of it, the human will only be a guard, or human don't really need to be there, because all of this generated logic graph goes through the human in the loop coding insurance in the future will go to the line number percentage. Then you don't really need a human in the loop. So this is basically the whole pipeline. And the package itself will be separated into two parts. One part is this Docs2KG package, which you can install and import it and run it on your documents. And the output will be a JSON file. And the second part of it is the interface. So this Docs2KG interface for you to upload the generated JSON file and then do the human annotation to make sure your generated entities are actually good enough. For example, here, I don't think this is correct, then I can remove it. This is good, I just don't care about it. And this is not correct, we want to update it, then we're trying to re-annotate that. So this is the second part of it. It will allow you to upload the generated one. And after you do the annotation, it will still be able to export one. And also you will have metrics automatically generated from that. So you can see the contribution for each methodologies, the manual process, and also what's their retention, like how many of them was being removed, how many was being kept, and the details of that. So with these tools, we want to be able to, at least the first goal is, with some effort, the human and the machine, the large language work together, you can have a good knowledge graph ready for the production usage if it's a one-off behavior, not a stream processing. And during this process, by this way, we can understand each like the model's contribution and their problems. We can try to gradually improve their performance until this kind of process here, human manual effort will go to as close as zero. The distance will as close as zero. That's our ultimate goal. So in this way, in return, we can be able to like boost the development and research of these different logic graph construction methodologies. That's the second goal. And the end of the goal is we're trying to be able to have a very good logic graph for the rack in the downstream task, but that's a lot of people was doing that. We just want to contribute our part. So we were first demonstrating how can we use the Docs2KG locally. We're trying to create a new project called Docs2KG. And all you needed to do is you need to create a new environment as we demo. We recommend you use the Python 3.1. And then after this installation, we then install Docs2KG. So after you're doing this, it will automatically go through and install all the dependencies. Our current version should be 3.2, 0.3.2. And then we can try to create a main file. And we should go to prepare something. For example, here we have the configuration example. This is an example about how should we configure our, because we have, okay, and here now the installation is done and we can see it's ready to go. And before we started, we need to set up our configurations. So you can see in the configurations, we have many three chunks. One is data, another is agent setting, and then is a semantic KG. So for the input data directory, you basically, for example, if you run your code here, but you're processing the data actually on other disk, you can set it probably here. But for now, what I want to try is to just create a new folder for the data, and then I update it to the data folder. So it will be something like this and this. The ontology is the one you will save your entities, relation list, ontology JSON, and the domain descriptions here. So that's where you put it. And if you want to use OpenAI or the Azure OpenAI, you should set your keys here and your URLs here. But our use trying to use Onama. If you want to use Onama, then you will need to be install the Onama by yourself on your local, and then make sure the model running properly. You can also use the Hugging Face models, but you need to go Hugging Face to get the token. If you're trying to use the Llama CPP, then you need to download the colonization model and then put the model pass here so you can use it. For the entity list, we were basically trying to put it here, but we don't have it now. So we put a placeholder for now. We will add one while we are doing the things. So that's what we were trying to achieve. And then after you're doing that, as we said in the documentations here, you will need to either to set this configuration in your environment variable so we know where to look for this configuration file, or you need to, in your code, trying to set it up. So I think rather than just write it, we will try to copy the code and explain it to you a bit. So the top part is setting the environment variables. This one is because I haven't added the interactors. We will try to add it to make it looks properly. Docs2KG, okay. And it should work probably. So for now, we should be able to have the content we need to get it run. But however, you definitely will hit an error, which means like we don't have this file in our local because we don't have that data things. And we also don't have the thematic layout stuff. So it will definitely throw an error. Let's try to run it first to see what's the error will be showing up. It will take a while. And another thing to notice is because we use a spicy, so before you run it, you need to run this command. Okay, it's been started. It's actually being able to looking into these configure files and load it successfully. And that's kind of the secret key or the stuffs we need. And it says we don't have this folder. So we needed to put that file here. Let's say we have an input folder. We have output folder. We have output folder. And for the input folder, we actually want to have a file there. We have a file there. This is the PDF we find the processing. And we do it again. Oh, that's because this is the error I forget to mention. You need to run this before you start it because we needed this one to do the entity list construction. And like I just doing it in a like a reactive way because I want to show you guys all the errors you possibly will be encountering and how to solve that. It's we're hit another error, which is because we are lacking of another file is this entity list. I will show you what's inside the entity list and what's the format you need to follow, but yeah. Okay, for now, this document was being processed successfully, but because we don't have the entity list is empty actually, so it cannot do anything. But what's inside of this entity list is something like this. You should have the entity and entity type. For example, this is a geology concept, which is core concept. You go downwards, this is a very long list we exported from the relational database. For example, this is a project in Western Australia. And then after I have this, I will rerun it again. You can see it says there is no this entity list of files, but now we have it. It will be different now. And compared to the code here, this one have constructed the PDF and do the PDF process. Output is this markdown. And then after this markdown, we construct a project. And within the project, we're trying to construct a layout knowledge graph, which is here. So it's actually have a layout knowledge graph is this one. And we have the schema about the mappings of the layout schema. You actually can bring up your own. So if you want to define your own layout schema, you actually can define it and put it here if you are not a standard PDF. But if it is, then you can use ours. And then after this step, it will go into the stage using this layout JSON. It will go into the semantic layout construction. Semantic knowledge graph construction, which is a name entity extraction one. This is the one based on the entity list. And to do the match, after the match, we'll return an entity list. It will go through, ask the large language model, say, this is my entity type, this is my entity, and this is a text. Is that a proper entity extraction from this given text? If yes, return yes. If not, return no. And then after the large language model do the filter and judgment, we will filter out the incorrect one, just keep the correct one. So this is a process you have seen here is trying to call the large language model and doing all the processing for the documents. You can see some of them are correct, some of them are not when it's trying to doing the things. So you can see the extracted entities is ID. We will give it the ID and starting end. Text is what and what's the label and the confidence of it. And what's a mask construct this so we can track back who doing this good or who doing this bad. So it's potentially will take a while because it's a very long list of the documentations. Let's see how long it is. It's 40 pages. And because it's layout specific, so you will be split into multiple of them. So it will take a while. But afterwards, after it's take a while to get the output, you will being able to see it from here. The entity list will have contents. For example, here. No, that's not a good example because we haven't waiting for that to finish. So this is a good example here. So you can see from here, it will have the entity list of all the things. But as we said, like most of them, you don't really know whether it's correct or not. For example, the disclaimer here is definitely is wrong, right? And it's use large language model to do the extraction, and it have low confidence. So we definitely needed something to be able to visualize it and easily delete it if it's wrong. If it's correct, then we still keep it here. That's the next stage of it. We will have this kind of interface for it. We will show you later. But for now, this process have done. So you can see this is output file we just generated. For some of them, you will have this entity list. Oh, no, not this. But I think we have some. Yeah, you can see there are some entities being generated. For example, this is a concept. That's a pretty correct one, actually, because this is a pretty specific word in this domain. And this one, it's correct, but I'm not sure whether it's correct enough in this context. So we need to go back to check that. And that's one way of doing like the name entity extraction, which is entity list based. You can also import another methodology from the thematic NER, which is a prompt based. So let's see for this. And then, like we have done here, you can just do it in this way. You add another line of code and you give it a project ID. And I don't think we need the Bob things anymore. We need the example JSON. And all of the things we don't need it, we need the project ID. And this is another way to doing the entity extraction, which is using the large language model directly to do that. You can see some of them being extracted. So that's the way most of the tools was provided. So it will go to ask the large language model to generate one. But here, what we are doing is in our ontology, we actually will generate the list of the entity types, and from the entity types, we will put it in the prompt and doing the generation. So it will, and we will do the post evaluation to make sure it's correct and locate it back to specific places. And then we will save it together with other methodologies generated in entities. And so we can verify it later. So that's another way we can do it. For the ontology itself, if you have an ontology, how can you feed in and get that to be included in the prompt? So this is one of the formats you can do for the ontology. So you just need to have the entity type and the relation types. This will be updated automatically if you provide an entity list. So it will be updated automatically. You don't really need to be like manually updated. And we also provide a methodology, ask the large language model to generate a list of the entity types and the relation types and the connections based on the domain tags you provided. It can be a long summary of it. The large language model can help you to do the ontology. After it's generated this one, you can come here and do the update, like a human verification, this file to make sure all the entity list and relation types and the connections between them are making sense. This is the ontology. And then this process will also take consider of it. So the example code actually is in the code itself, which is here, or ontology. So you can see this is how you generated the entity names. We're using a prompt to do that. If you have much better ways to do that, you can try to implement it in your way. But that's generally how can you use that. You can import it and like doing these generations, and your output typically will be something here. And then that's the next step, which is a second stage, human. Large language model has done its part of the work. So how should the human do the work? So you can come to our platform. You can basically register account freely, and then you will be taken to the places only have this project, which is a demo project we want to show you. Everyone can see it. But if you want to start your project, then you just need to give a description, and you have a private project, and you create it. That's a private one. And you go to this page, and just now this generated JSON, it can be uploaded. And then into this page, you can see you have a lot of layout, different layout chunks. For example, this is from the table, this is from a table, this is from the paragraph, and it will have the different types of entities. You will be first prompted with alert. This means in your current entity list, which you can set it here. So ontology, you can also set it here. You can upload the entity list that we just show you from here, and it will automatically update the entities and the relation types. For now, it is a clean project, so you don't have anything. So all of these kind of entities, you can see the color here is a bit like a black. So it will ask you to say, do you want to add it to the ontology? If you add, it will be included, or you want to remove it. If you want to remove it, all of the annotations for this one will be removed. For example, we do remove for some and add for some. We can see the differences later. So you can see in the settings, the thing you added have been shown up here and here. And if you think this one is incorrect, you can do in the re-annotation. But until you resolve all of them, this alert mark won't disappear. And then here you can go through it one by one, and then say, okay, this is correct or not, to review all of them. And you can switch to the relation mode. For example, this is a relation mode, but for now we don't have the relation, right? So we need to define a relation. A general one is related to. You should have your own relations in your context, but that's what we will do here. So you do the LICO related to, or you can actually say this is a relation type, but this is the relation content, and it will all be included here, showing up here. After you go through one by one and doing all of the annotations, you will be able to save it and download a updated one. And then you will be able to see the performance. We have mentioned that the human and automatically generated distance, now this is 58%, which means a lot of them are being deleted. The statics can be shown up here. So for example, the contribution of this methodology is 98%. 73 of the entities are being kept, but there are several of them are being deleted. The manual one contributes that much. And for the relations, human, the manual one contribute all because we haven't do the relation detection there. And the details of added and removed entities can be seen here. So from this one, you will be able to understand the contributions of each methodologies and what's the real problems you're trying to address later, which is very useful. And when you go into this page, because it's a Docs2KG, if you have another file, you're trying to upload it, you will have it. And then if you're trying to see multiple files together, what's the performance? It's very easy and straightforward. So for example, we say we accept all of them. So both these two should have different performance. For example, here, this one. Yeah, this one here is 0 because the human and the machine should be the same. And because you definitely want to see overall the whole project what's the performance, you can just click this one. That's the overall one. So you can see it will be all being included. That's the overall performance. If you just want to see for specific several documents what's the metrics, you can select them together and then see the metrics from here. So this will give you the idea about how can you improve the methodologies to to improve your log graph, and you can download it and take that output to your downstream tasks for generation. So that's basically all. And in the website, you should be able to see a lot of descriptions there. And for the tutorial, if later you want to extend with a new methodology to generate log graph, it's actually very simple. The end of the goal is like you just want to update the layout JSON, add a new entities, a new relations from there, and say what is the methodology created that. And then you upload this JSON file to our package. So it's all decoupled. You don't really need to log into our packages if you don't really want. But if you want to contribute new ways to construct a log graph for the public benefits, you can also do that. So that's all. If you have any questions or problems, you can send us an email. All questions, we will try to help you. And if you have any new features you want to request, you just need to send me an email. That's all. Thank you.